Dr.Nouby, can you please let me share my screen? Dr.Nouby.
Yes, Dr. Ibrahim.
Can you please let me share my screen?
Okay. Available now.
Okay, thank you very much. I think we should wait also for other people to join. So if you just let me know when should I start.
Okay.
Dr.
Good
Abdulaziz.
afternoon, everyone.
Dr. Abdulaziz.
I am Dr. Abdulaziz Ahmed.
You can start now. Okay, you can start, Dr. Abdulaziz.
Start?
Yes.
Okay. Okay. Good afternoon, everyone. I am Dr. Abdulaziz Ahmed. I am an assistant professor at the Faculty of Graduate Studies for Statistical Research. First, I would like to thank Dr.Nouby Ghazali for his invitation to be the chair of this session of the third International Conference on Engineering, Science, and Technology. Second, I would like to welcome with all audience and the presenter. The session will be from 1:30 until 3:30. There will be 4 presentations, and every presenter will have 25 minutes for his presentation, followed by 5 minutes for questions. Now, I have the great pleasure for introducing the first presenter, Professor Ibrahim. Professor Ibrahim will present a research paper entitled Adversarial Attacks and Defense Strategy in Machine Learning. Dr. Ibrahim?
Hello, Dr. Abdulaziz. Thank you very much for a nice
Ibrahim?
introduction. Yes? Yes, can you hear me? Dr. Abdulaziz, can you hear me?
Start, Dr. Ibrahim, now.
Okay, can you hear me?
Yes, you can start.
Okay, thank you very much. So,
yes.
yeah. So we have 25 minutes.
Please, can you hide the volume?
I cannot increase the volume because it's already okay. I don't know how to increase the volume, in fact. So you cannot hear me?
From your computer, you can have increase the volume of the sound.
Is it better now, or it's much?
Yes, now it's better. Yes, now it's better.
Okay. So I will talk today about those adversarial attacks and the defense strategies in machine learning. So first of all, thank you very much for being with you today in the third international conference on engineering, science, and technology. So I will first I want to say something about myself. So I'm working as a professor at Norwegian University of Science and Technology, and I'm working as head of international master program in simulation and visualization, and the department deputy head for research and innovation. About my background, I have my bachelor degree and a master degree in control system design from Egypt. I have PhD in artificial intelligence from South Korea. I have also PhD in field robotics from Aarhus University in Denmark. And now, in this period, my research focus is in area of control, expert system, optimization, and machine learning. So I will just give some snapshots of some of my previous work, which is related to machine learning. I will give a very brief introduction to machine learning, and after that, I will talk about those attacks and the defense strategies. So this is one project which we use machine learning, in fact, to solve. It's route predictive maintenance using deep learning. So we try to use machine learning here to try to predict remaining useful life of routes. And in fact, we applied it in Norway because in Norway they scan roads 2 times per year, and they collect images. Each image it's 20 meters length. And those images are used for documentations and also for checking the quality of roads. And they do this process, in fact, manually. So they have big rooms, screens, and when someone complains from some part of the roads, they go to that specific area and they try to see images and they try to decide if we need to do maintenance or not. So the idea here was to build a machine learning which can help us to save this manual time and inspection, and try to predict the remaining useful life of routes using machine learning, and try to display it in a map in a predictive way. So in fact, we predict a score, and this score represents remaining useful life of routes, and this number will be 1, for example. If it is perfect, it's just a very fine road, and it will be a number close to 0 when it's really bad and need maintenance. And we display it. We build an API where people can upload any kind of images of roads for sure, and we try to predict this number remaining useful life and display it in a map. And then when you press in the map, you can go to that specific part and check it. So in fact, it's end-to-end implementations. Another project also, it's a key joint structure segmentation. And this segmentation time also, if we will do it manually, it takes hours, in fact, for each patient. So they mentioned that it takes around 4.5 hours for each single patient. And the idea here also is to try to exploit deep learning techniques to try to automate this process. And we try different types of machine learning models, and we can do this process, in fact, in few minutes or few seconds instead of few hours, which is very, very important. I mean, after segmentations into different type of tissues, we can build a 3D model for a knee, for example, and we can also build a model to make early diagnosis, because I mean, sometimes it takes time for people to go to hospitals and get the right diagnosis. So the idea here is to try to automate this process. So it's also idea of using machine learning in such application. Prognostics and health management for air compressors. Today we try to build this autonomous vehicles or autonomous boats. These autonomous boats, it has engines and it has tools. The idea here is to try to build a system which can predict faults in those tools. So we try to answer 3 questions. Is there any fault, which is anomaly detection? Which fault, which is a diagnosis? And then when a fault will occur, which is prognosis. This is very, very important in the area of autonomous vehicles or autonomous ships, which is coming in the near future. I mean, when we buy new instrument, we have startup region, for example, where we have very high number of failures. We are expecting very high number of failures when we buy a new stuff, and therefore they recommend us to switch those things on in the beginning. And after that, we will have this normal life. And after a certain time, we will have those equipment will start to worn out, and it will start to develop some failures. So the idea here, try to predict when this will occur and what kind of failures we have. Dr. Ali Tameli today, he was presenting this MCA, which is excellent. It's a very, very innovative algorithm, in fact. And I went through his paper. It's very nice. So it's automated offshore crane design using online crane prototyping tool. It's a kind of optimization. We try, to build this crane. This crane, it has very high weight in tons, and also we try to build it to satisfy some customers' needs, for example. So in fact, it's optimization problem, and the idea here is to automate this process using optimization algorithm, similar to what Dr. Ali was presenting today before lunch break. So the idea here is to use different types of optimization algorithms, single objective, multi-objective optimization algorithms to build those offshore cranes. Because it's a multi-objective, in fact, because we try to maximize load and we try to minimize at the same time weight, because they build it in a ship. And at the same time, also try to minimize the cost. So it's a multi-objective optimization problem. And my question, which I couldn't ask today to Dr. Ali, in fact, how can we use his MCA for solving multi-objective optimization problems? I have been working also in best planning for line marking robots building this line marking robots. In fact, this paper was my paper in I guess it was 2012 or something. And now there is a big company working in this, in fact. So we try to automate the process of plotting those lines in football stadiums using robotic solution and using RTK GPS. And this is a simulation also for doing this one. It's a very simple application, but it works a lot, in fact, because those football stadiums, it takes hours for plotting those lines. And the idea also is to automate this process and using robotics for plotting it in few minutes instead of hiring people for doing this process. So this is robot which is in the market at the moment, in fact, for plotting those white lines on football stadiums. So we can plot those lines. So I have been working also in testing best planning for 3D field coverage algorithms in agriculture. If we need to do some seeding, some harvesting, we need to automate also this process. And the idea here is to use an autonomous vehicle for doing this process. But to do this process, you need to represent the field in 3D. And after that, you need to generate those trajectories which will guide the autonomous vehicle. And in this case, in fact, we will have this tractor, for example, without this driving area here. We don't need a driver. We don't need a human driver. And the idea is to build maybe a mobile app, for example, so the farmer can press a button and his field will be seeded, for example, or harvested automatically. So I did the same application also, in fact, in Egypt in landmine clearance. And this has been done in I mean, in North Egypt, we have this landmines. It's a problem because those large areas of land, it's not in use because of landmine. And the idea here is to build a landmine detection. Landmine detection, there are many systems, but the idea here is to generate a trajectory which you can guide this robot in a systematic way and to put some marks in some locations when it detects marks. So much bigger vehicle, for example, can go and try to clean it. I have been working also in this adaptive surveying and early detection of treatment of crops with team of autonomous vehicles. It was an EU project, in fact. And it's a way for, in fact, it's this project, in fact, we have a quadcopter, and this quadcopter will take aerial images of a land, for example, of a field. And from this aerial images, we'll try to detect locations which has weed, and we can send the unmanned vehicle to that locations and try to spray it or deal with it, for example. So in this case, they can try to minimize amount of herbicides maybe by 95% or more. So I have been working also, I established this social robots lab also in fact in 2016. And the idea from this social robots lab is to try to build robots which can deal with older people. I mean, you know, older people in Europe, they are in big number, and they live in nursing homes, for example, or at their homes. And the idea here is to build a system to keep those people more independent as long as possible. So the idea here is to build a system which can be used in daily life in nursing homes and in private homes as well. So we have been building robots, and those robots can talk to the people in natural language. We use natural language processing. We can build user profiling for patient and for a robot as well. So the robot can know the status of the person. If the status is okay, is fine. For example, as a personal trainer, if the person is performing a training each day, for example, he can try to detect and try to identify this progress, for example. We have been in the media several times, in the newspapers and in the TV also. Some people supporting this idea for using robots in nursing homes to take care of all the people. And some people, of course, are against it. But the idea here is to build a system which can support nurses in nursing homes, because in the future, it will be impossible to keep the same services as it is today without using technology, because to train and to educate nurses, it takes time and it's expensive. It's at some point it's very, very important to use technology to support them. Some people don't like it, in fact, and they need we need to have this warm hand. For example, we cannot rely on robots. Some people are against it because it's against humanity, for example, but it's technology, and we have to deal with this in the future. This is a personal trainer which we developed, in fact. So we have this nice interface, and in this nice interface, you can tell a joke, you can sing a song. In fact, you can do some personal trainer with all the people. So, for example, look training the upper part of the body while they are sitting in their chair. This is very, very important, because in nursing homes, for example, they can hire people to provide this personal trainer maybe for 30 minutes or something per week, one time per week. But it's impossible to have people to do it daily, for example. So the idea here is to build a robot which can provide this service to all the people at a daily basis, for example. I mean, this robot, it can tell jokes, it can say something about news, for example, it can sing a song. So it's very, very nice to be used with all the people. And as you can see from these videos, they are engaged and they are happy with the robot. I know some people here, as they have been in a very bad mood at morning, and after having a session with the robot, they become very happy and enjoy a lot working with the robot. So I want to go quickly because we don't have time. So we have been using also robot in education, for example. So for example, if you have a presentation to your students, instead of presenting it by yourself, for example, you can upload your presentation to the laptop and the robot will try to present it for you. So the idea here is to save your time. I mean, if you have a teacher, we need to save his time, so we can use his time with students with special needs, for example, or try to focus with individual students instead of just presenting his material. So the robot can just present his material, and the teacher can use the time in something else which is more useful. In entertainment also, in fact, in opening in a big building or a company, we use those robots to play a song with a guitarist. So they have been working with him. It was very nice. In fact, we used the paper robot for doing this, and it was simple because some students from bachelor and master they had been programming it. So I want to talk about machine learning. So the timeline of machine learning, we knew it. I mean, it started in 1940 with McLuch bits. Do you remember McLuch bits? Is this very simple perceptron. I can just say it's a perceptron. It's where we have very simple model. It was just a very simple model, similar to I mean, it was very simple. It was just weighted sum of inputs plus some bias. So we started in 1940 with this McLuch bits, and at that time they mentioned that they called it electronic brain. So they overestimated its ability, in fact, at the time. And in 1950 it has been developed. So they developed an algorithm which can adjust weights, because when McLuch bits model was very simple model, and at that time they don't have a technique to adjust weights and bias, and they just try to adjust it manually according to each problem, and they overestimated this achievement at the time, and they mentioned that it's electronic brain. And when they write in newspapers that it's electronic brain, I mean hopes becomes very, very high, in fact. And it was a problem later on because they couldn't solve all problems using McLuch bits model. In 1950s, they developed this perceptron learning rule, which can be used for adjusting the weights of McLuch bits model, and they can solve more problems and automatically, in fact, adjusting weights. So they can work with data, learning from data instead of adjusting it manually. In 1960, we have this adaptive linear unit, which is nice because we can use it for regression problems and we can use it for classification problems. They discovered that simple problem like XOR, we cannot solve it before 1970, in fact. So 1969 or 1970, they solved this XOR problem. And 1980, I mean, to solve this XOR problem, in fact, you cannot solve it with a single perceptron. And the idea here, we need to connect some perceptrons together in a layer. So we can start with one hidden layer where we have two perceptrons, one output layer where we have only one perceptron. So it looks like a multi-layer perceptron. In 1980, they developed this error bug propagation for training this multi-layer perceptron. In 2000, we have this support to vector machines, and the deep neural network started in 2006 or 2010. So this is very introduction. Types of learning in machine learning, we have three types. We have supervised, unsupervised, and we have supervised, unsupervised, and reinforcement learning. In supervised, we need to have a target, a signal, or features. We have some input features and we have target features, and we can use the target features for adjusting the weights of our model, so we can classify problems. Examples of from some application domains: text classifications into span and ham, for example, image classification, segmentations, regression, sentiment analysis, etc. This also has the disadvantage of closed loop set classifications, because if it is supervised, it must be closed set classification. We have both inputs and the target data sets came from the same classes. It's impossible to classify something which does not exist, for example. In unsupervised, the problem of supervised also, maybe 10% of the data worldwide is supervised. We have lots of data set around us, and it's very time consuming and very expensive to try to label those data to use it for supervised techniques. So as the idea came that we need to have this unsupervised, it's more general. So where no known answers or labels assigned to each data or each class of data, we create models that takes feature vector X as an input, and I try to transform it into another vector or into a value that can be used to solve a practical problem. It's open set classification, so it's normal that we have unknown class So unknown class is an option. For example, I have a set of data sets and I try to classify it. Maybe at testing time in the future, we will discover that there is a new class coming in. So in this case, it will be classified as an unknown class. So we need the user to go and try to give it a label, for example. So unsupervised learning, we have lots of data. We try to cluster it, for example, and we can cluster it into a set of, you just need to define number of clusters, for example. And after clustering it, for example, we need someone to go domain expert and give it a label, for example. We have, as an example, for example, which I try to give it to my students, for example, it's coins. I have coins, different types of coins. So we can classify those coins according to the weight, which is weight and the size, for example. I have the weight and the size. So according to the weight and the size, we can classify it into different classes, but the machine will not be able to understand which class is what. So we need someone to go and try to give it a label, for example. So in this case, we will get an ID number of each class, and we need a domain expert to give it a label, for example. We can use it in dimensionality reduction, where the input to the model will be feature vector, and the output also will be a feature vector, but it will be over fewer size. In outlier detection, also the output is a real number that indicates how this input vector will be different from the rest. In reinforcement learning, it's a framework for solving control problems such as autonomous driving. We have an agent who have an environment, and this agent to try to sense the environment and try to make some actions. Distribution of effort in machine learning. I mean, you know, we are working with data in machine learning. So working with data is very important because we learn from data. We try to train a model from data. So we should expect that people should spend maybe 80% of their time or of their workload working with data. And when deep learning was introduced, it simplifies this problem because we can just work with raw data as in deep learning models. This is very simple example, building how to build your first model. We can start with this McLuch-Betts model, for example. It's a very, very simple model, and the decision line would be summation of inputs. So it could be, for example, if I have x1 and x2, so the decision line would be x1 plus x2 equals theta. So the only parameter here in this model which we need to decide, in fact, it's the threshold value, which is theta. And the theta here, in fact, it's the intersection with the y-axis, and it's the only degree of freedom which we have. The problem of this model, it works only for linearly separable data sets, for example, and this is a problem because people get disappointed at the invention of this model, because this model cannot solve very simple problem like XOR problem, because this model, it is a decision line is a straight line, so it can work only with linearly separable model, and there is no learning mechanism also. So we have only here, we don't have weights. In fact, in this model, we don't have weights. So the model, I mean, the decision line will be x1 plus x2 equals theta. We don't have omega 1 x1 plus omega 2 x2. So we cannot control, in fact, the slope of the line, but we can just control only the intercept, y-intercept. This is a simple model for solving this AND gate, for example. So we have those 4 points from the AND gate truth table, for example. So we need to draw this line. So this line will be x1 plus x2 equals theta. We can select theta equal 2 here. So we need to do it manually, in fact, to build a model for our data. There is no mechanism for adjusting theta automatically. If we want it for solving OR gate, we just need to change the line into, we need to change the theta into 0.5, for example. So this is the only degree of freedom which we have. In 1969, they invented a perceptron and the perceptron learning rule, and it's upgrade to McLuch-Betts model, in fact. So they introduced those weights, and those weights can be used as a measure of importance of each weight, because each weight, each input is contributing to the decision-making process. So if x1 is contributing by 50%, we can say omega 1 equal 0.5. If x2 is contributing by 90%, we can just say omega 2 is 0.9. So omega 1 and omega 2, or the weights here, will be measure of importance of each input feature. They developed this perceptron learning rule, which is a learning mechanism, which is very simple. So it's omega equal omega plus error multiplied by x. When error is negative, we will try to reduce omega. When the error is positive, we will try to increase omega to adjust it. So we need to reach error equal 0. So this model, it's a nice model, but it's the same problem. Can we use it for solving the XOR problem? It's impossible because this one designed. Yeah.
Dr. Ibrahim.
Yes.
Please, 4 minutes more.
Okay. So I will just go
4
quickly.
minutes more. Okay.
Okay. So for feature engineering, for example, this is the XOR data set, for example, and if you need to solve it using linearly separable model, we can just try to use feature engineering techniques to try to find this decision line. If you will not use feature engineering, you need to find a very complex model like this one. So confusion matrix, I need to make evaluation for my model. So we use confusion matrix. So confusion matrix, we have the true positive, the true negative, false positive, false negative. So in fact, this confusion matrix, it's my introduction to the adversarial attacks. We try to build a model which can maximize all true positive and true negative across those diagonal and try to minimize those numbers. In adversarial attacks, we do the opposite. In fact, we attack a model to try to increase false positive and false negative. And imagine that you have a patient, for example, who is corona. He has been tested for corona, but he is false positive. So he doesn't have corona, but we said no, he is false positive. He has corona, for example. So he will take some unnecessary medicine, which is a problem. Maybe it can make a problem for him, but it's not a big problem for the society. So we call it type 1 error. On the other side, we can have one who does not have corona, for example, and he has corona. In fact, we can just say that he is false negative. He doesn't have. So in this case, we will allow him to go around without taking for this 10 days quarantine, for example. So it will be a problem for the society. He will spread the disease. So the problem here, in fact, in those adversarial attacks, we try to increase false positive and false negative, and there are two types of those adversarial attacks. One called white box, one called the black box. White box means we need to get access to the model which we need to attack. Black box means the model we cannot get access to the model itself, but we can try to send the queries to the model and try to get some information from this black box model. So the problem here, we have some original image which we need to classify. If your model is working perfect, this is an image of cat, it will be classified as cat. But in case of adversarial attacks, we try to design some noise and add this noise to the input image. And in this case, the image will be classified as, for example, as a dog. So this was the adversarial attack. We'll try to push systems, we'll try to force systems to misclassify items. And of course, it could cause lots of problems for governments, for companies, and so on. We can do the same for image. We can do it also for text sentiment analysis, for example. So if you can add some noise to a text, this one has been, this first sentence, in fact, was clever. It has been given a score of 83% as negative. And when you try to add some noise to this text, for example, it will be classified as positive sentiment by 65%. So adding some noise to the text will make it a problem. Of course, this one can be a huge problem. For example, in a bank, when you send a question to the bank, there is a chatbot which will answer you, for example. If someone can get between the customer and the bank and the chatbot, and they try to add some noise, well-designed noise, to the message or to the questions, he will get different answer. So in this case, the bank might lose customers or might make wrong decisions. Two types of attacks, targeted and non-targeted. When it's targeted, we need to force the system to decide some, to classify items into some certain target or certain class. Non-targeted, we try to make the classifier to give an incorrect result. So it's incorrect, and that is all, but not specific cluster. So how can we fix those systems? By using those adversarial training. Adversarial training means we will try to generate those adversarial examples and train the model using those adversarial examples. So the model will have better immunity against adversarial attacks. So I think I don't have enough time. But I can just give you an example. Yes. So here, for example, something we have here. This is a picture of panda, for example. And if we can add some white noise, it's not white noise. It's a very well designed noise. In fact, we add it to the original image, so we can classify it as something else. Adversarial batches also, it's designed to attack any scene and default the image classifier to output any chosen target class. Even when the batches are small, in fact, they cause the classifier to ignore the other items in the scene and they cause the classifier to output any chosen target class. So this is an example. This one is classified as banana, for example. And when we put this image for toaster, for example, it will be classified as a toaster. But when we add those batches, when we add those designed batches, the banana will be classified as a toaster. And you can just imagine the consequences. Maybe you are applying for a loan from the bank, for example, and you apply your data. Maybe based on your information, you should not get a loan. But if we can add some noise to your data, maybe the bank will decide that you should get a loan, and maybe you will not be able to pay back to the bank, so the bank will have lots of troubles. It's the same, for example, it's microwave against phone, for example. This one can be classified as a microwave. If we added some gravity here, if we have added some dispatch to the image, which is not possible for people to see, in fact, to recognize, it will be classified as a phone. We have another problem, the stop sign attack, for example. This is something very important for autonomous vehicles, for example. You have this stop sign. The car should, when we have this image, when we have this picture in the road, for example, we should stop. But in fact, because there is a machine learning, and the machine learning will take this image and it will classify it as something else, it should classify it as a stop sign or something else. We can attack those models. We can use those also adversarial attacks also, and they try to misclassify this stop sign into speed limit 45. So for the autonomous vehicle, instead of stopping, it will continue driving and it will make an accident, for example. So this is also fully license plate detections and recognition. It's especially in parking places, for example. So we have this one. This is actual license plate, for example. And designing a machine learning, we can misclassify this one as something else, for example. So someone else will pay for your parking. In time series, it's also something very, very important. So imagine that we have this ECG data set for a patient, for example, and by adding some simple noise, adding some noise to one of those signals, it can be classified as something else, for example. So maybe he has a heart problem. You cannot identify those heart problems from the original signal because we try to add some small noise. Maybe doctors cannot recognize it, but the machine will misclassify it into something else. So in fact, there are lots of, I guess it's just my, I just finished those time. So I mean, the last part was very quick. So thank you very much.
Thank you, Dr. Ibrahim.
Thank you.
Thank you so much for your presentation. Are there any question from audience? Any question? Any question from audience? Okay, Dr. Ibrahim, I have one question, please.
Yes.
Please, please go
yes,
to page 26.
Yes.
26.
Yes. So the timeline for machine learning. Is it correct?
This 26?
Yes.
A minute.
You want to
please go forward.
Okay, forward.
Ah, yes, here, 27. Okay.
Okay.
27.
Yes.
27. Yes, 27.
So types of learning in machine learning supervised.
Ah, yes. You said closed set classification, both input data, target data set come from the same class. Yes.
Yes.
But I think it is not mandatory. When the target data set may be from many classes, other than the test set.
No, I mean in supervised learning, for example. So I have a data set to classify it into dogs and the cats, for example.
Okay.
Right?
Data set with many classes. The set with many classes.
Yes, multi-class, of course, multi-class classification. Yes, of course. So I have dog and the cat, for example,
yes.
And I have my data sets for supervised. It's for dogs and the cats, and each image will be classified either to dog or cat, right? So if I give you, for example, a picture of an elephant, it will be classified into a dog or a cat, for example, right? So it will be classified as an elephant because I don't have an elephant in my supervised data set.
But also maybe outside the classes, I can say the supervised or the model can detect this image is out of the class.
Yes, but if you will take care, or if you will consider this when you are preparing your data set, for example, so I can just say that I have a class which is unknown, for example. But you need to consider this in preparing your data set before building your model. But in supervised learning, we have some target features, we have some those target features are specified, and you need to decide, okay, I have to classify all my inputs into 2 classes, for example, or 3 classes or 5 classes. But if you get something outside those, it will be misclassified into one of those predefined classes or labels. But in case of unsupervised, in
my opinion, the model must be general. So if I have any image outside the classes, he said it's out of the classes, no problem.
But if you have a label called unknown, for example, right? So in building your data set, for example, if I want to classify into dog and a cat and unknown, for example, so in this case, I need to prepare a data set for this, and also it will be closed sets, right? So I have 3 classes. So if you said dog, cat, so it will be 2 classes. Even if you said unknown, it will be also unknown, right? But I don't know which is unknown, right? So I can give you a picture of an elephant, a picture for example, monkey, for example. Both will be classified into unknown, right? But in case of unsupervised, when you have your data set, it will be classified into a number of classes according to the feature set which I have. And I need a domain expert to go to the output of my model, and it will give it a label. So it will say, okay, this bunch of data sets, this bunch of clusters, this cluster will be dog, this cluster will be cat, this cluster, it will be monkeys, this cluster will be elephants, for example. In the future, if you got something different also in the future, it will be possible to generate a new cluster or a new cluster for those new coming data set. So when it's unsupervised, it will be more dynamic, and it will consider those. So it will have this kind of dynamic in my data set in the future. So it will not be across the set classification problem. Yes. Is it okay, Dr. Abdulaziz?
Okay.
Hello?
Thank you, Dr. Ibrahim. Thank you so much for your presentation and your answer for my questions.
Thank you.
Now, okay, Dr. You hear me?
Yes.
Hello?
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 Yes, Dr. Abdulaziz, I can hear you.
Thank you, Dr. Ibrahim. Thank you so much. Thank you very much for your answer to my question, Dr. and your presentation. Now, the second presenter, Deepak, will present a research paper entitled Financial Crime Detection Using Machine Learning Approach. Dr. Deepak? Dr. Deepak? Can you hear me? Dr. Deepak?
Yeah, can you see me? Yeah, no problem. Yeah.
Dr. Deepak?
Yeah, can
yes,
you hear me?
you can start now, Dr. Deepak.
Okay.
Yes, yes.
So no problem. Okay, no problem. So let me go for this one.
Please present your presentation. Display your presentation.
Can you see my presentation?
No, not appear now. Yes.
Okay, so no problem.
It is Kabul, yes?
Yeah. Okay, no problem. So let me start one by one. Okay, so basically today I will be talk about the financial crime methodology using the machine learning algorithm. So in our talk, actually, I will be cover the what is a financial crime, different types of financial crime. Then I will take the one of the case study in the KYC and the credit card, and I'm just trying to give the walkthrough about this one of the case study for this credit card fraud detection, and I'm just doing the comparative analysis, and this will I talk about the and this I will talk about the one of the solution actually I use for the anti-money laundering, how it can be useful. So that is overall my outline of my presentation. So yeah, that's it. So basically, when I'm talking about the financial crime, correct? So financial crime, why is very important about that? So you know that finance has actually become the very important part of our life, and even also if you stay on our earth, the finance is very important for us also. And in the today's world, you know that the peoples are trying to go for the online methodology for the financial crime. Due to the COVID-19, the people are trying to avoid the close contacts and they are trying to motivate it for the online contacts. That's been going for the more for the financial. Because of that, there is a more actually threat for the financial crime. Also, people are in the world actually they can use a different kind of models, methods, or to detect the financial crime. So when I'm talking about a financial crime, I'm talking about that. Now, if you want to see like how much industry are spending money to detect the financial crime, basically to tackle the financial crime. Basically, if you want to see the figure, this is I just got the figure from the Cloudera. Basically, that is one of the software I use actually as a part of our implementation. So in that particular thing, what I found that so cloud in the world, the people are spending $1.28 trillion for tackling the basically I'm talking about the financial crime problems. And after that, if you want the financial crime has happened, there is 1.45 trillion loss was happened. But you know that there is about 100% cases, there is 1% cases are actually successfully so for that. So now you can see that how the machine learning can be useful to solve the different types of financial crime. When talking about the financial crime is a very vast area, like there is a bribery, corruptions are there, money laundering, cybercrime, fraud, theft, and human trafficking. These are different 6 areas are there. But in that particular different areas are there. If you want to build taxonomy, like credit card fraud is there, KYC fraud is there, loan fraud is there, home loan fraud is there. I'm talking about debit card fraud is there. Then I'm talking about gift cash fraud is there. Those are different kind of fraud segments out there. So basically, financial crime is very vast area, and this is I'm just talking about that. In the future, also I just talk about that. Cyber crime is the one of the area that people can be more focused onto that. Please increase the volume. My volume is it better right now? Hello,
Yes,
my
Dr.
voice
Deepak,
audible?
yes.
Okay, sorry. Okay, sorry about that. So this is
No
I'm
problem.
just talking about the financial crime. Now I'm just giving some of the examples of the I just told about that. Okay. So this is I'm just talking about the some of the examples I'm talking about the financial crime. So I'm just taking the one of the scenario. Today the financial crime is attack is actually happened. This is one of them talking about the cyber crime scenario. I'm just giving the one of the incidents happened in India. So there was one bank was there. So what they did that in the bank, they actually set up the virtual network gateway, and what they're actually they are doing all the transactions and that particular network gateway, they actually trying to approve some kind of transaction, and they actually realized that 100 crores got transferred. And after that, there is a certain kind of alert got raised, different types of pattern was there detected by the financial crime system, and they actually discarded all their infrastructure from this one. But till that time, they actually their 100 crore got transferred, and they found that the attack was there. What was doing the financial crime? It is worldwide. There are some of the people from India, Hong Kong, Europe, or Mid Asia. So these are talking about the performing all the transactions, and they're all the monies are transaction to the different number. What they did actually, they actually opened some dummy same accounts, and they're taking the money and they're transferring about that. It is overall I'm talking about the strategy was given, and it is very difficult to detect this kind of attack. That I'm talking about the one of cyber crime is there. In the future, I'm talking about like there are cyber crimes are there. There are different types of credit card is there, debit card fraud. I can say the giving gift kind of scam is there. The different types of scam was I'm talking about the scammers often. If you want to know the basically a different kind of a phishing kind of thing, I'm just giving the some of the example. If it's just for a knowledge purpose only. So this is I'm just talking about the rental scam is there, CEO fraud is there, fake invoice, beneficiary account, Nigeria in maybe I'm talking about the spearing phishing, those kind of things are there. Now these are different types of frauds are there. These I'm trying. So how I'm detecting that, correct? Now if you want to detecting about that, I am actually getting all the data in terms of the 170 gigabytes, 1 terabytes. Right? If I want to understand the if you want to do kind of building any kind of language, correct? So what I think about that, if you want to build any kind of language, correct? My language basically, my approach should be as per the all the government standard, because I cannot go for detect and final outcome, because what are the things that it should be approved and certify the respective government body and compliances also, that I'm taking care of as a part of my research. Parallelly, I'm just talking about that when I'm taking an algorithm, correct? That algorithm based I'm talking about that, it should be, if you want to see the volume of data, I'm getting 174 zettabytes, and I'm talking about that 10,007 gigabytes is 10,012 gigabytes, and I'm talking about 7 zettabytes I'm getting. That data I'm getting from the different around the world. Second thing, if you want to take the data of the format, the data is I'm talking about biometrics, video, call centers, or the legacy kind of. When I'm talking about biometrics, that maybe I can talking about the people can be make a recording of voice, and they're talking about voice also. They can be talking about some facial masking. They can do video call. Maybe when I'm talking about behavior, other I'm talking about video conducting. So recently, I just talking about as a part of my research. So we are actually developing one algorithm with a behavior kind of algorithm, because if the one of the person actually talking to the one of the call center or one of the banking center, if we are asking kind of initial statement, so what I can do, I can ask a name, I can ask a date of birth, I can ask about something. If I found that that particular person actually reading something about that, because if you know the confident answer, you can understand that the way of the customer speaking. If the one customer you want to read the transaction, you can say just wait for the 5 minutes, something like that. You can take the pause, you can give the transaction, what type transaction, what types of. So based on that behavior kind of analytics, we can identify that this is one of the financial crime, this is one of the fraud user is there. You can identify that. So I'm talking about the call centers today, because there are lots of information that call centers which can be sold by the website, that I can the dark websites that it can be sold about that. Maybe I'm talking about some of the videos are there, because right now some of the banking people the video banking, but who is the right person about that, or they can see that. That I'm talking about the different type of new data sources. So when I'm talking about developing any kind of machine learning algorithm, because I'm getting the 175 zettabyte data, I'm taking 1 terabyte data. That particular data basically, I'm talking about what is the algorithm I'm talking about. It should be time complexity and space complexity. It should be scalable. It should be reliability, availability, and the performance factor is very, very important, because for my as a industry, when I'm developing a solution for my customer, I think about this factor, because I have to give the result within the fractions of a second, in millipart of the second. That is the objectives are there. That is I'm talking about more performance agnostic kind of systems are there. And here I'm not talking about preventive or proactive. I'm talking about reactive approach. What kind of immediate decision I should be taking. Parallelly, when I'm talking about other phase also, I'm talking about that. How I can maintain the security governance, I'm talking about that. How I'm trying to avoid the duplicative kind of effort which can be avoided by the company. Maybe how I can use the existing my knowledge based database, how I can do. These are some of the factors I consider while choosing any kind of machine learning algorithm. So these are some of the area I'm just talking about that, like internal surveillance, we did that. I'm just talking about one of system as a part of my research. Because you got a laptop, you're working for a company, you got a mobile. In the mobile also, you can take the pictures of all the transaction, and you can save as an image also. But we know that if any person is still doing kind of mobile transaction, so what are the automatic programs are that immediately got activated, and it will try to capture all the information. He capture what kind of information capture that. And that I'm talking about the internal surveillance, because you know that as per the reports, there are 70% of major of threats are occurred by the internal employee compared to the external employees. So how I can do the user behavior analytics as a part of internal surveillance as a financial crime detection, that I was talking about that. These are some of the factors I consider as a part of my research. And when I'm talking about that, I actually use a system is called as a Cloudera, and we actually use some of the system, like I got the data from the real time. Actually, I use the approach is called as a 6-stage, basically 6-stage approach. I got the ingestion of the data, how I can processing it, how I can store my data, how I can analyze, build the model, and the display. Because once you got the ingest the data also correct, you got that particular data. That data is containing the noise pattern, missing values are there, null values are there. How I can do explore data analysis. And how I can store the data in terms of very effective kind of thing. Once I store my data, how I can do the analysis of my data in the real time, that I'm talking about that. Now, how I can build a model, means what I'm talking the model, I'm talking what kind of machine learning model or deep learning model I will be applied to detect my financial crime. Then I'm talking about that once the model is ready, how I can deploy this model into rapidly into the cloud platform or on premises. That's a single touch kind of thing. Those are the things I'm consider as a part of my platform, as of my research. And that's why I'm just talking about that. I'm just trying to build a financial platform on the cloud era. I'm actually using the Python also as a tool. These are some of the tools we actually use as a part of our code only. So let's think about so this is I'm just talking about some of the financial crime. When I'm talking about the financial crime, so there are different types of areas are there, correct? I'm talking about the KYC, credit card is there, debit card is there, home loan fraud is there. I'm talking about the award phishing are there, correct? Here I'm talking about what is the majority threat of my as a financial crime. First I'm talking about the KYC, correct? Now to take the example like that. Now when you're in normally as a part of our India, but right now I'm in Australia, but right now in the part of India, suppose you want to apply for any credit card or debit card, what normal people are they are actually normally giving their Aadhaar card, PAN card, everything, information, hard copy, bank statement also, the address proof also, there lots of things are there as hard copy. Now think about that. If you are giving this information to the one of the agent, what he will do that he will try to sell the information to the third party also, and he can sell the information to the customer also. Now what will be happen in that particular case actually, correct? If the one of the person, he can be take my data also, he can apply for the fraud loan behalf of my name, he can take the loan. After that I can get a call from the bank, you took the loan. That I'm talking about fraud. But how will detect this kind of fraud at the beginning itself? I'm talking about that. That was my challenge is there. So what I talk about that, once I got the data, I'm filling all the information. Once I'm filling my all the information, so what I'm trying to do that, let me show to something you. So this is I'm just talking about the building some kind of, we're talking about the holistic KYC based model. What I'm trying to do that particular model only. So basically we actually I use some of the reference from the McKinsey, one of the consulting company. I actually use their reference also. What we did there actually, we got the data. Parallelly, we are collecting the data from the different kind of social media platform, LinkedIn, social media, so like Facebook, Twitter, or Google, Facebook. Maybe I'm trying to get the information from the other activity also. What I'm trying to do that, if the one person is profiled all the information, we are collecting all the information. We are trying to see that what is the how the unique names are there based on certain criteria. Unique name, unique numbers. I'm talking about that. I'm talking about that at what time he's got to apply the data. That's I'm talking about that. Now I'm talking about age also, because sometimes the age can be different also. And when I'm talking about what kind of transaction he did that, what kind of this, that all gets the information. Now what I am doing that when I'm talking about that particular profile is a fake or not, what I'm trying to do that actually I'm going for the two levels of operation basically. One, I'm talking about the first level of operation who can do the investigation using my machine learning algorithm. What I'm trying to do that if my first name is Deepak Mani is there, I will take that particular name. Sometimes he's forgot to mention my name also. I will take my address, because if I'm submitting my documents also, he can give me local address. But my Facebook profile showing that I'm located is based in Sydney also. Even also my LinkedIn profile, they can check my numbers also. They can see my post also. That I can see also. And that is the way actually I'm just talking about that what kind of fraud will be happen. So based on what I'm to cut out that, I will just give that. You know that there are certain kind of internal threats of the officers are there who is actually offering the loan also. He can once a profile is got there is an investigation officer is there, he will just I'm just got all the data. What I'm trying to do that I'm just trying to apply the three types of machine learning algorithm. So that already I just some of the selection told about that. Supervised learning, unsupervised reinforcement. In the supervised learning, actually I'm doing the classification. What kind of cases can be handled by the level 1 investigation officer? Which cases we can have level 2? I'm talking about classification. Level 2, I'm talking about some of the regression algorithm I can use is. In our case, I actually most of the use boost kind of algorithm. AdaBoost, XGBoost, I'm use the algorithm. I'm actually SVM algorithm, I can use that. Parallelly, I'm just talking about that like that is first. Second, I'm talking about that if you want to identify that, because any KYC forms are there, in what location most of the fraud was happening, I want to generate what I can do. I can go for the cluster based algorithm. I can do the clustering based on some names and all those. That I'm talking about clustering based kind of KYC is there. And what I'm talking about, when my case is there, it is very difficult to, if I approve this case, if I want to know that what is the effect will be happen on that particular, what is the impact on that, what is the impact on my brand of my company, how much loss will be there. If I do those kind of reinforcement based on my historical data, I can do that. That's what I'm talking about. Those are the different kind of sets of algorithm we actually use as a part of the KYC. And we're just talking about that. Okay, based on that information, we're just making the classification of the profile like that. When I'm talking about the black like it is no, I'm talking about the blue one, I'm talking just go approval. Basically it can be I'm talking about it can be escalated to the second level of this one, and green I'm talking about I'm giving the first level. So what I'm talking about, I'm just trying to give the matrix of the scoring profile based on the matrix, and I'm just trying to give the depth of consistency, and I'm talking to go or no. That's I'm talking preparing some kind of chart so that it can be helpful to the who is the investigation or the upload officer. He can make a decision about my KYC, he's the right person or not. That I'm talking about KYC procedure. I'm talking about that. This is I'm just talking very this in that in our case as a part of that, what we did that we actually as a part of the algorithms, we actually use the different types of algorithm like ADA boost, those kind of algorithm actually use that, and I'm just trying to use some kind of this one. So let me show the something about that. So this is the I'm just talking about the credit card, but actually I use the same kind of thing. And let me I'm checking that what kind of algorithm I have to use that. In our case, I'm actually using random forest, ADA forest, cat boost, execution, light GBM. Because these are the 5 popular algorithms actually used by the financial crime. Because if you want to use an algorithm, the lots of algorithms are there. But why base I'm talking about that? Actually, I use the McKinsey reports as a base format to present my algorithm to them only. That was the base I'm talking about. I use that. And based on that algorithm, what I talk about that, let me explain. I'm just actually use the same approach. So I just talk about that. I just take the explore data analysis my first phase. I'm just talking about what my missing data is there. Then actually I decided my approach. I just talking about my features. That features I'm talking about variable, that is column name. It is univariable or bivariable, multivariable, or it is continuous or discrete, or it is changing, or what kind of parameters I'm talking about. But this I'm just talking about this one. After that, I'm actually taking the data exploration. I'm just talking about the patterns and all those things. How many transactions are performed by the per hour basis. Maybe I'm just talking about in the KYC sometimes what's happened. In the one day, the people are using 100 KYC from one particular region for the one particular person. That kind of patterns will be there. I will think about why this person in the more applications form, because my target is then how is achieve the 100%. So what I can do, there's some kind of suspicious things will be happen that I can do it. That is one of the kind of fraud it can be happen. So I can do the kind of fraud, kind of KYC fraud I can detect also. And just give the another example as to the one of the best example I want to give show about that. So like this one. So this is one of the I'm just talking about the one of the fraud where actually I was talking about that, because this is one of the new fraud actually came across. What he found that in India, basically, actually I ordered my credit card, and that order of the credit card is actually going to different people's actually, different person. And when I was called that particular call center, I told them that I didn't receive the this one, like I didn't receive my credit card. So what said that? But your status is showing I received my credit cards. I told how my credit card will receive that, but I didn't receive that. What the when the person said that when the deliverable that we already give the person the right person something like that. Now how I can do the starting my analysis? Now what we did that we collect the, because you know that once the credit card is given the correct, so what that particular person did that particular machine actually storing some of the internal data about language lottery method, what kind of information we collected, the all information that particular device he has a side, and he actually having a SIM card, and automatically that information get updated to the this one. So we got the all the longer lateral information. I got the address also. When I got the address, I put longer latitude. Now what he found that most of the credits card, because this I got X and Y longer latitude to this one, but I've been getting A and B. I found this is fraud. That person is saying about that, and most of the time what's happened, these kind of similar pattern was happened to the in that particular different persons are there, and this is the one of the we found out that there's a credit card deliverable kind of fraud is happening as a financial crime, and in that particular thing also there are some delivery boys are connected to that, and that information is not here because the daily life the person is busy, they cannot keep about that. This is the way we are talking about fraud has happened. So what we're talking about that based on the language latitude we're talking about, that is the one of the way we are detecting the fraud. That I'm talking about the detection of the fraud basis for the credit card kind of thing. Is a credit card issuer or deliverable kind of fraud. Again, this is I'm talking about the financial crime fraud is there. So this is I'm just talking about the credit card fraud detection. So this is I'm just talking about the some kind of comparison study. So basically, like I said, talking about that, once you got the data also, correct, that we have to identify that, like, once you got the data, correct, now I have to identify that, like, how the person, how
Dr.
the,
Deepak?
I can classify the, yeah.
You are finished? But the time is over.
Okay, so just I'm taking the time. Okay, so these are I'm just talking about some of the things are there, and these are the algorithm series, modes, hybrid or sampling data, neighbor-based classifier, k-means cluster algorithm. Those are lots of algorithms I actually use. So that's what just okay. So thanks for this. If anyone have a question, they can ask me.
Thank you, Dr. Deepak, for your presentation. Now, are there any questions from the audience? Any question? Okay, Dr. Deepak, I have only one question, please.
Yeah, tell me, sir.
Dr. Deepak, please,
there, yeah.
the credit card fraud detection is not new problem, yes?
Credit card is not new problem, but you have to identify the what are the different types of fraud
Yes.
is happening, correct? Now the asset told about that. People are more intelligent.
So what is your contribution? And what is the difference between your model and other models?
See, basically, my model is more talking about that. When I'm talking about industry, I'm just considering about my size of the data set. That's the one thing. Second, I'm talking about what is algorithm solution. That algorithm supports the parallelism. It is talking about the scalability, reliability, availability factor. Third, I'm talking about the deployments are there, and lights. I'm talking about what
okay.
models are there.
I think it will be better if you present a small comparison between your model and other models depending on some criteria.
Okay, sure. I will share that presentation to you. Right? So I don't have because the industry data. That's why I couldn't present about that.
Thank you, Dr. Deepak. Thank you so much for your presentation. Thank you, and see you again in Egypt, inshallah.